convection, evaporation, and condensation. All these processes involve particles. Conduction is the movement of thermal energy through a material without the particles in the material moving. Glass, wood, and plastic all are poor conductors of heat. Heat is the kinetic energy of particles as they vibrate. If we heat the particles at one end of a material, the particles at that end vibrate more and bump into the neighboring particles, which causes them to vibrate more. They collide with their neighbors, and so the energy passes from one particle to another through the material. Metals are very good conductors of heat energy because there is a second process at work. Metals have free electrons. The free electrons gain extra kinetic energy at the warm end of the material. They diffuse to cooler areas where they collide with the particles in the material, transferring their kinetic energy. Convection happens in fluids. The heat energy moves through the material as the particles in the material move through the material. Hot liquids and gases rise because when they are heated, they expand and become less dense. The less dense warm liquid or gas then floats up through the more dense cold liquids and gases. Cold liquids and gases sink because when cooled, they contract and become more dense. The more dense cold liquids and gases sink down through the less dense warm liquids and gases. These changes in density causes the convection currents in the liquids or gases. Snow, sea, cloud. It's not often you see the three main states of matter in the same place at the same time. But I got lucky one chilly day earlier this year walking on the beach just after a snowstorm. The clouds were still heavy with water vapor waiting to fall. There was a dusting of snow on the beach, and the ocean was licking in and out, in and out. There, right in front of my eyes, was water in its three states, all together at once. Now you can see three states of different substances anytime you like. Open the door of your refrigerator and you will see all kinds of liquids chilling in jars, solid lumps of vegetables and cheese, and the whole chiller cabinet bursting with invisible gases like oxygen, nitrogen, carbon dioxide, and the various other lesser known ones such as argon that make up the air around us. But it's not often you see three states of the same substance all together at once. Ever wondered why? Let's take a closer look. What's the difference between a solid, a liquid, and a gas? You might think it's just a matter of temperature, but there's more to it than that. In solids, atoms are bonded fairly firmly together, though they do move about a bit. You don't need to put a solid in a container. It stays where it is because its atoms are locked tightly into a definite shape that ordinarily doesn't change. If a solid is reasonably soft and you press it, you can make it change shape by pushing its atoms into new positions. Heat a solid enough and you will give its atoms enough energy to break apart, forming a liquid. In liquids, the atoms are more randomly arranged and a little bit further apart. The forces between them are weaker and they can jiggle about and flow past one another quite easily. That's why liquids pour. Take enough heat away from a liquid and the atoms will slow down until they form a solid. Add some more heat and some of the atoms can escape from it to form a gas. Gases have much more randomly arranged atoms than either liquids or solids. The forces between the atoms are very weak, so the atoms can spread around freely with lots of energy. A liquid can flow, but a gas goes one better and expands to fill all the space available to it. If you squeeze a gas really hard or take heat away from it, its molecules have to huddle together. Pretty soon they're bonding to form a liquid. Keep squeezing or cooling, and you will lock them together tightly to make a solid. On the left, solids are more dense than liquids. They have more atoms packed into the same space. The atoms are tightly packed together and stay in shape all by themselves, though they do move about on the spot. In the middle, liquids are usually less dense than solids but more dense than gases. Their atoms can move around much more, so they need a container to keep them in place. Although diagrams in books often exaggerate the spacing, it's important to note that the atoms in liquids are almost as close together as they are in solids. To the right, gases are even less dense than liquids. Their atoms go where they please, so they need a completely sealed container to keep them in a place.